Hi, welcome to this new video. We're going to talk about our section 2.2 of this midterm exam. In this video, we are going to talk about the most important axioms in probability. So we have some of the main laws of the probability. In probability. The first one, and the general one, and the most important, is about every probability of a sample A have to be more than zero. Why? Because if we have probability of minus, this didn't make us sense. Because if we have a probability that is minus, it doesn't have any um, doesn't have any uh, well that didn't count. Okay, we don't know. We don't need it. We have to move to positive to have a result that can be convenient in our studies. So this have to be positive. Have to be positive. Then another action is about for a number of uh, of e's. We are going to say is like a sample for a number of people, for a number of animals, for a number of something. We have E, E2, E3 until En. So for a number of that, we have a summatory of n over 1. We have P equals to the probability of all of these one, to En, have to be 1. We have to normalize that we don't want experience out of the 100%. If it's bigger than the 100%, our sample, our experiment, our probability is going to be not that good. Okay, and if we have it uh, less than 1, we are missing some data. So we have to normalize. Have to be normalized. Be normalized. Now I'm going to put this here. We don't want experience. These are experience. The letter E, experience out of the 100. As we said in our lection 1, or midterm videos about the section 1.1 and 2 in the book, we know that if we don't have our sample of the data inside that our data is not related to our to our main result, we don't have a relationship between it. So like in the mean, if we have 100 in a one digit experience, we are going to have an anomaly in our experiment, and we are going to have a number that is not inside of the parameters. So well, out of the 100%. Another axioms is about the symmetry, and for one, about the symmetry of experience, the probability of the symmetry of the experience, and the union. These are unions. The union of the experience 1, and the union with the experience 2, and the union of the experience 3, and the union of an experience. We can do this because every single one of these experiments are independent one of each other. No, any of the experiments has a relationship between it. There are no experiments in the example. Experiment 1 doesn't depend on the experiment 2. These experiments have the same event and is going to give a result independent from each other. So we can have a union of them. And this is going to be part of our sample, and the sample is going to give us a probability. So have to be independent. Independent. That's a T. Now, this is an obvious one. If we have a probability of 0, this have to be 0. And it's all. We have to have 0 on our zeros because we don't have that. Then if we have the probability of A, oh my God, what is that? Oh, this is another thing. The probability of A plus the probability of as we saw in the last class, this is a complement we have here. The complement, P, the plus the complement, they have to be 1 because if we have our universe, we have A and we have the complement. So this is going to be all of the universe. So it's A plus the complement A, it have to be 1 universe. Another axiom is about the probability of A1 have to be less than 1. And why? We can exceed 1. We can't exceed 1 because first, because the action that we already have here, this one, we can exceed 1. And the one we can exceed it because the first, the second is the second action. The second action in this word right here, this one, second action. And this one is the same. So we have a probability, and if we have more than 1, it means that it's not in this here. We are taking something from the universe. Now, we can talk about another action. It's about the intersections. So first, we have this equation, the union of A and B have to be determined by the probability of A plus the probability of B, because there are two different populations, minus the probability of the union of the intersection, the intersection between A and B. Graphically, we can look at this. Oh my God, this is horrible. We can see this. We have A here, B here, and inside of this, we have the intersection A intersecting B. So we have to rest this one to have our union. So it's going to be all of this data. Oh my God, all of this data, not the one that is in black. Now, if we have the probability to be, if we have a bag and we have 10 things inside, we have only one opportunity to take one thing from the bag. We are going to say that we have only one probability, one probability to choose something. So we have P is going to be 1, the number of times that we can take, over N, that is the things that are inside the bag. So we have 1/10. So this is going to be the probability of being chosen. So we have 3 times, and we have the bag with 10 things there. So we can do it 3 times. So we can take one, okay, it's a 1. So put it inside again. And then we have the bag and we take it again. Oh, it's an 8. Put it again. And we have another time, and it's a 2. So we have 3 times to do it. So this is the probability of the interaction, we're going to say it like this, an interaction between the bag and your hand going to happen 3 times. So we have the probability of happen 3 times is equal to 3/10. The formula that we are using is P equal to the number of times that the interaction happened over the number of data. This is going to be all for this video. We know that we can do the experiment 3 times or more. We can do the same experiments a lot of times, and we could have the probability to take a number a fraction of time. So, well, this is the video for today. Thank you for your time and have a nice day.